Okay, everyone, hello. Welcome to another live stream. I wasn't planning on doing any live streams today, but I think it will be a fun time if I'm just working and just streaming a little bit. So today, as you can see in the title, we've moved on from the URL shortener project because I just thought it was a little bit more complicated. I mean, the setup was just rough around the edges. I just didn't think about it very thoroughly, so there were some details that I just missed out in the beginning, and therefore, when I was setting up the whole functionality, I just thought, well, it's just not worth it. Okay, so let's just move on from that project. I think even though I will leave it out as like unfinished, so to speak, I did learn some things about, especially about the cloud environment. So I think it was very helpful. I mean, at least in the beginning, but then I just thought, well, I mean, it's just too complicated. I'm just not going to finish it. So we've moved on. Now I'm going to do another project, which, as you can see in the title, is named Conduit. I'm not entirely sure how to pronounce that, but it's just based off of this website right here, which is called Real World. I'm pretty sure a lot of people, it's pretty well known in this space. Um, it's just like a mock implementation of a Medium clone. I don't know, Medium just like the social media that's made up of a lot of articles, and you can have your own spaces and post your own blogs and just your own articles. So this project just aims to replicate that functionality. As you can see, the features are very similar. You have authentication. You can just update users, create users, read users. You can query on articles, comments, and then you can also favorite articles, and then you can also follow users, which is going to be a really interesting mechanism and just an overall, well, interesting functionality to implement. I've never done anything like this, especially because since we're using a cloud environment in a serverless fashion, I think it's going to be really interesting. And also, I think it's going to be a really nice practice project because, I mean, it's just the main objective of this sort of initiative, right? Just to practice a little bit with any technology that you want. So yeah, I'm going to be using the same stack pretty much that I was using on the last project. I'm going to be using AWS, Lambdas, DynamoDB, API Gateway. And for the API, I'm going to be using Golang, but instead of using Fiverr, I'm going to use Chi, which is just a lightweight router. It's just basically a wrapper around the net HTTP package. Nothing too fancy, nothing too heavyweight. I'm not going to use a lot of functionality, so I just might as well just use something really lightweight. Wait, sorry. So as I was saying, this practice environment is going to be really helpful. The functionality is not really that complex. By the way, we're going to just focus on the backend specifications because I mean I don't do front end, mainly because I mean I just kind of hate CSS and HTML. But I mean we can I can do it if it is strictly necessary. But it's not something that I enjoy, so I'm just going to skip that part out. And then as for the rest of the application, so the backend of course, I'm going to be implementing basically everything. As you can see, we also have a testing part, which is the only part that I'm going to skip, basically because I just want to do a lot of projects besides this one. So the faster I finish this one, the better, because I want to practice a lot more of technologies and a lot more of stacks, maybe even WebSocket implementation, not just a REST API, maybe even a little bit of GraphQL, a little bit of machine learning, who knows. I'm just practicing a lot of stuff, basically because I want to gain some experience in the cloud. So yeah, I mean that's basically it. I'm not going to enter in too much detail. As you can see, we'll be working on this for a good like what 2 hours maybe or something like that. Of course, I'm not going to finish because I mean it's a lot of functionalities, and also because the data modeling, I mean it has been a hell. Like literally designing the data for DynamoDB, it's one of the worst things that I have done in my life. As you can see, I have a lot of planning in notes right here. Well, I mean, you probably can see it that much, but I've been planning this like since yesterday, and wow, that thing is just insane. Like, you just literally cannot imagine how different it is from the traditional SQL data modeling. Like, it has so many caveats and so many like special cases that you have to handle, especially because you have to design your data around your access pattern. So it's not like you have to model the data intuitively into the models that you have, so that like a model just represents a real life object. So in this case, for example, a model would be like an article, or a model would be like the user. But you cannot do that directly in DynamoDB because you cannot have multiple tables. Like, you can have multiple tables, but optimally you want to avoid having multiple tables because it's not what the database is meant to be used like, if that makes sense. So you will see how this goes. I'm not even sure if it's going to work. I mean, I've seen some suggestions that I should implement secondary indexes or indices, and then I should just query information in different ways. I mean, I can tweak a lot of stuff. So, I mean, it's not too late to rewrite this whole data model, but it's just a complete pain. Like, it's just painful to design this, especially when you don't have a lot of experience. I mean, I guess starting with SQL, it's a lot easier because it's more intuitive, but as you gain experience, it just becomes second nature, right? I don't know if this thing will ever become second nature for me, but I mean, I guess we will try. Who knows? Maybe it does. But I mean, we'll just give it a try. I mean, what's the worst thing that could happen, right? Maybe that I end up paying like $100 in AWS. Who cares? I mean, it's part of the fun. Maybe not. Maybe not end up living in the streets, but I mean, let's just give it a try, right? I mean, let's go. So, I mean, we'll start working out on this thing. As you can see, the introduction just presents you with a bunch of like useful information, like a Postman collection. You also have a starter kit to create a new implementation, but I mean, we're not going to create a new implementation from like the template. We're not creating even an implementation. We're just literally just practicing around. So we're not going to do all of this setup and just like boilerplate to create a new repo or anything. We're just going to head straight to the functionality. So if you can, as you can see, the first thing that this suggests is authentication. But I mean, I'm going to show you what I have right now. It's not a whole lot. So basically, I literally just have a lot of setup code. So as with the last time with the URL shortener project, I did some work off camera. So I literally just implemented a bunch of boilerplate, as I said. We're going to use a caching system just like last time. In this case, we're going to use a Redis client. So, fun fact, by the way, my machine doesn't support Windows subsystem for Linux. So we're basically in a huge trouble because I cannot use neither Docker images, so I cannot test this thing locally, and I cannot either install a Redis client locally. So I'm literally just doing this thing. Wait, let me just check something. I think, oh yeah, session has expired. But I'm literally using the Redis cloud service. You know, like I think this was like a year ago, a couple years ago, I don't even remember. But when Redis went like an enterprise model with a cloud integrated and all of that stuff, people were hating on it because, I mean, of course, right? Like, who wants a cloud integrated environment when you have like literally the best key value pair database in the market? Like, I mean, it was just completely unnecessary. But I guess it is necessary for me right now because since I cannot install Redis locally, I have to literally use a server in the cloud. And this thing, I mean, it was really easy to set up, so I just thought about and said like, I mean, just go ahead, right? Might as well just give it a try. Who cares? It's fine. So instead of installing Redis locally, I'm literally using this client right here. Of course, when I deploy it to the cloud, we're going to use Elasticache, the same service that I was talking about last time. So don't worry about that. I think we're going to do just fine in the cloud. I haven't tried this locally. Literally, the only test that I did was just for connecting to it, which is this line right here near Redis client, which is in this area right here. So I just literally define all the variables in the .env file. Of course, I'm not going to open it, But I literally just define all the values over there, and then I'm literally just reading them right here. So I'm doing a lookup env, and then I was loading it with the go.env, so that all the env variables were loaded up in here. And then I'm literally just reading it, and I haven't even done any operations. So I guess we're going to check it out. If it works, well, I mean, nice, right? But if it doesn't work, I mean, I guess we'll have to just go blindly with the cloud server directly, because it's just such a shame that my computer doesn't support WSL. I don't even know why that happens. I was reading a lot of GitHub repos about it, and the comments, I think it was an issue that someone opened, that it was particularly on a certain model of computers, and well, my computer happens to be one of those models. So what happens is that when I install it, the whole resolution of the screen just lowers down and sort of downgrades. So instead of, my resolution right now is like 1920 by 1080, but then when I download the WSL, I don't know why it just turns down to like 1080 by 720 or something like that. I mean, it just looks horrible. And then the performance is also downgraded, so everything just runs so slowly and just looks horrible. Like, it's just a complete mess. I cannot work with that thing. So yeah, I mean, I cannot install WSL, and therefore I cannot install neither Docker nor the Redis client locally. So yes, I'm sorry about that. And that's also one of the main reasons why I'm not doing testing, because, you know, I mean, I cannot install the thing. So we're not doing testing, we're not doing Docker, we're not doing the optimal stuff that I should be using, because I mean, of course, everyone is using Docker. So sadly, I'm going to have to use this thing right here, which is the DynamoDB local implementation, which is just literally like running a server in your local computer using Java. Like, who uses Java to run a server? That's just horrendous. Of course, I should be using Docker, as I said earlier, but I mean, it's just such a shame, right? But anyways, I mean, if it works, it works. Who cares what I'm using? So we'll be doing that. By the way, I haven't checked the error here. I'm just going to do just so this thing stops complaining. Panic could not delete table. So this thing is, it's just like for checking if the table is actually up and running. So if it exists, it drops down the table and then it recreates it again. So in this line, we are creating it back. So this is just that when I create this server and I start to run it, like right over here, when I do something like HTTP, listen and serve, blah, blah, blah. So when I run the server down here, what is going to happen is that each time that I run the server, it's going to drop the database and then run it again. So it's just kind of like a migration, but it's just manual. So I'm going to do a lot of mock-up data as well, I think. And then that's basically the testing framework that we will have. I mean, it's not very sophisticated. It's not even optimal, but I guess it works. We'll see if it works, by the way. But anyways, so we're going to start the timer. As I said, we're going to be working like 2 sessions probably. I don't know what time it is. 10:21. It's fine. So yeah, we're going to start right away. So the first thing that I want to do is to create the models. So of course we're going to do that first. So models. I just called it models. So we're going to do a lot of models. Well, not a lot, but just a bunch of them. So we're going to use a base model, by the way, because I'm going to show you the structure of the database right now. So, wait, oops. By the way, you shouldn't have seen that env file. Let me just close everything, and then we'll go back. Okay. So as I was saying, wait a minute. Okay, so as I was saying, I have created a database already, so the test setup that I have right here is going to be literally the same that I'm going to deploy and I'm going to define with the CDK later. But what we'll basically do, and I'm going to explain a little bit of the data model right now, is that we're going to have 2 keys. So of course, DynamoDB uses a two-part primary key system, so to speak. So you have a partition key and a sort key. The partition key is mandatory, so you cannot skip it, but the sort key is optional. So I'm going to use both on this one because it's a somewhat complex system. For the partition key, we're going to store basically the main entity. So what I'm planning to do, I'm going to just show you in a notepad right now. So I'm going to model the data in such a way that the primary key, the partition key, is in a sort of hierarchical relationship with the sort key. So what I mean by that is that if, for example, I have an entity called user, right, and it has the ID 123, for example, and then I have a secondary key that is, for example, an article, which is article 345, for example, right? So as you can see, with this one right here, we're defining a relationship because what we have a user that has written an article. So that means that the user is the author of the article, and therefore there's a relationship, right? So the article belongs to the user, and a user can have many articles. So it's sort of like a one-to-many relationship. And then what I'm going to do, so as I explained it, it's going to be like a hierarchical relationship. And then we're also going to use another attribute, or sort of like another column, or yeah, like an attribute inside of DynamoDB that is going to be type. Which, for example, in this one right here, the type is going to be like article, because what we're defining in that row of data is just an article, right? We're going to detail the title of the article, the slug, the contents, the description, an image, or etc., right? So another type of relationships, for example, is going to be the follow relationships. So for the follow relationships, what we're going to do is we're just going to do user number 123, for example, and then we're going to define a special type of secondary key, which is going to be something like follows, and then 456, which again, it establishes a relationship between the two. So that's what I'm looking for with this model, that the PK and the SK both have sort of like a relationship, and then the PK is kind of like the top of the relationship. So like hierarchically speaking, the PK is going to be like the parent of the SK, if that makes sense. So we're going to see that in like a real example later on. But yeah, that's what I'm trying to achieve. So for example, in this relationship right here, the user 123 follows 456. What that means is that, by the way, we can be more specific right here. So for example, we can do something like follows, hashtag user, hashtag 456. And that way there's no ambiguity, so to speak, on this one, that a user follows another user, right? So for example, in this case, the user 123 follows the user 456. And then we can also do the inverse. So for example, the user 456 is followed by user, and then 123. So each time a user follows another user, for example, we're going to do this two-way relationship. It's not a two-way relationship. We're just doing like the inverse, like the normal relationship and the inverse at the same time, because then we would want to query the followers of that user, and then all the followers will be notified when that user publishes a new article, for example. So there's a feed functionality for this project that is going to be really interesting to implement. I think it's going to be the most interesting part of this whole project, the feed functionality, because it works sort of like social media. I mean, it is a social media, right? But it's not exactly a social media, because it's just missing a lot of stuff like the recommendation algorithm. It's just a basic feed algorithm that it's going to query all of the followers and then just post all of the articles of the people you follow. So yeah, I mean, that's the way it will work. I think it's pretty decent. I mean, it doesn't look anything extremely complicated. So I'm going to define a base model right here. So base model struct. So we will have a PK, which is going to be a string, and then we have to do type annotations as well. So DynamoDB AB is going to be PK, and then for the JSON, we're not going to do JSON on these ones. We're going to do it on the request and response objects, which we're going to define later on. But for this one, we're just going to define the DynamoDB, because this one will be the ones interacting directly with DynamoDB. So this is going to be a string also, DynamoDB attribute value. It's going to be called sort key. And then we will also have a type, which is going to be also a string. And then we will have the classic created at, which is a string. A string that is going to be parsed onto a native date.time object in Go, by the way. I'm not entirely sure if I should. I will just use Pascal case for this one. So yeah, this is going to be all of the attributes that are going to be shared across each and every like model inside my application. So yeah, we're going to do. So first of all, we're going to do user.go package models type user struct. Okay. So let's see. So for this one, we're going to do extend the base model, and then we'll define our attributes right here. So I'm just going to check out, sorry, what are the attributes that are defined right here. So it returns a user. Let's see how that looks. I think I have another one right here. So user, let's see, for authentication, we have a user and then we have a profile, I think. Yep. So the profile and the user, I mean, it just omits a little bit of information, but for the user, we need the email, the token, username, biography, and then an image. Okay. So I don't know, I'm not exactly sure. Okay, so we'll have to store the password as well, of course. So we're going to do an email. The token is going to be stored elsewhere. Our username, bio, and image. Okay. So we will have an email. We will have a password. We will have a username. We'll have a bio. And then we'll have an image, which is also going to be string. Okay. Email, password, username, bio, and then image. Okay. So I mean, this is literally just like the PFP or the profile picture. And then what else do we need? So I think that's it for the user. As you can see right here for the profile, we're just doing a following thing right here, but this, I mean, we can just query that in the database later on. Okay, let's just now do article. So for this one, let's see, base model, we need a slug, which is just a string. Then we need a title, which is also a string. We need a description. We need a body. We need a tag list, which is an array of string. We need a, well, created ad, updated ad, we already have that ones. Favorites count, author, okay, we need the author one as well. So this is probably a user embedded struct, and then we're going to do, sorry, let's just group that one. So let's just copy that. Description. Body. Tag list. which I think in DynamoDB you also have a string array, so we can store that as a string array. And then, or we can also do the classic, like more relational approach, which is just going to be store a row for each tag that we append to the article, I guess. DynamoDB attribute value author. Okay. So for the author, I think we're going to just do author ID. I think it's just a better approach. We're going to do an integer right here. Okay. So that's for the article. We also need a comment. So type comment struct extends the base model, and then for the comments, let's see what we have. We have the ID created at the body and the author. So we're just going to do something like body, and then author ID, which is just going to be an int. And then we're going to store right here body DynamoDB author ID. Okay. So that's basically all that we need for the base models of pretty much anything. I think we can also do a tag. I'm not sure if we're going to use this one, but sure, why not? Type tag struct base model, and then we're going to do for the tag, we're just going to do something like a title or name. And then, so this is name, list of tags. Yep, we literally just need the name of it. So, okay. So we have basically everything that we need. Okay. So after defining the models, we will have to define our store, which is going to be defined right here. So I'm going to do a user store, a article store, and then a comment store, I think. So yeah, we will just do that one. User store.go. By the way, we're going to rename this local setup just to match the convention. So what we're going to do is just define a bunch of methods right here. So we're going to define the behavior of our database and what operations we can do against it. So DynamoDB database, we're going to start with the user store, which is going to be, I mean, just really simple CRU. I think it was in the features. So if you check right here on the features, CRU, so create, read, and update users, sign up and settings page, no deleting required, so we're not going to delete any users. So we're going to do the register part first. Create new users. So this is another like important aspect of it, of like this architecture. By the way, we're using the same layered architecture that I was using in the shorten URL project, which is just like divided in models and then domain and finally the application layer. So what I mean by this is just that when we create, by the way, I have a typo right there. Inside of our model layer, or like sort of like database layer, so to speak, what we want to do is just define the operations in a way that we're literally just interacting with the database. So like all of the data, it has been processed and received through a pipeline, which is just like the application first, and then it goes downward to the domain layer, and then finally it goes to the last level, which is the database layer. So we're defining these methods in such a way that we're literally just processing the data that it has been already validated and has been already received, so to speak. So when we're developing the code for the database, we're assuming that all of the data is valid and that we have all the data that we need already, right? So because of that, we're defining the methods in such a way that it matches this interface right here. So create, read, and update. We're not going to do any validate user or receive user. We're not going to do any HTTP methods because that's going to be a responsibility of the application and domain layer. So again, right, we're using these three operations, so we're going to do literally just that. We're going to do create new user, update user, and then get user. So we're working with one user at a time each time, so we're not going to do a query on the user entity, so to speak. We're going to do just a get item because we're going to retrieve only one user at a time. So with that in mind, we're going to do context, which is just context.context. This is for the SDK purposes. It's not something that I know exactly how it works or how the AWS internal uses it, but it's needed for the framework. So we're going to do context.context, and then for creating a new user, we need the user model that we have, right? So models.user, and then we're going to call this new user. And then what we're going to return is just an error, right? So we can just return a nil right now. We're going to do this update user. So we're going to leave it as a stop for now. There you go. Okay, so for creating the new user, of course, we have access to our client, which is our DynamoDB client, and we also have access to our cache client. So we're not going to use the cache client for registering new users, I think. We're just going to use it for, querying, I guess, and then also updating for some cases, I think, but not for creating, so we're just going to ignore it for now. But then also another thing that we have to decide is where do we hash our passwords for the user, right? So I think we're going to assume that the password is not hashed yet, or we can also assume that it's going to be hashed inside the domain layer, which is one layer up from where we are right now. So because of that, we can do either the hashing right here, or we can leave the responsibility for the domain layer. I think we're going to just leave the responsibility in the upper layer because right here I just want to keep it very, very simple. I just literally want to store the user directly. Like, we don't care about validation and processing of data. We're just storing things and reading things and retrieving things and all of that stuff. So yeah, we're going to do just that. We're going to do client and then put item. So the context and then put item input. So this has to be put item input. So we need, I think we need a table name. Do we need a table name? Yes, we do. Data table name. String, oh, I think just, oops, okay. The dot table name, and then we can also do, we can also do just something like this and this, just to be sure about it. Oops, sorry, I don't know why the Go server is so laggy. I hate that. It's the only complaint I have for this language. Like, the LSP server is just so bad, so slow. I don't know if it's my computer. I wouldn't be surprised since I cannot even use WSL in this computer, but it's just so disgusting. Anyways, so we also need our item, which is a match string of attribute values. I think we can just I don't remember how you did that. exactly. I think it was something like Marshall or something like attribute value. Wait, let me just check it out. We're going to do sorry. Let me just check if this works. Let's see. Put item, let's see. Item AV, yeah, you have to import the attribute value library. So that's right here, DynamoDB attribute value. I don't know if it is installed already. Let me just install it. Let's see. So we can just do something like go get, and then just remove this quotation marks. Okay, nice. So technically it is installed right here. Let's see if this auto completes because it's so laggy, like goddamn. Map, Marshall map. Okay, there you go. So we can just do something like new user. Then we can call this a v error. So classic snippet, if error. See if it loads. God damn it. If error. We can just do something like, I want to be very expressive with this error, so I'm going to do error format. Could not create a new user, and then we just print the original value of the error. And then we can just do a v right here. Nice. And then we can just return, I think this returns an error as well. Let's see, put item output error, so yeah, we don't care about that one. So return, let's see, so this is basically this error right here. I don't know why I put it over there. Return okay, there you go. So we're literally just storing the user, right? We're not even like doing any validations or creating a new password hashing or anything like that. We're just literally just storing the user. So the same applies for the other methods. For example, right here, the update user, we just want to, for example, I think let's see, I think what we can do is literally just the same signature as up there. Models, the user. Let's see, I think we can do just like a star right here. Yeah, that's fine. I think it's fine. So as I was saying, we can do literally just the same signature as up there, but with the difference that this time we're not going to do put item, instead we're going to do update item. So let's see, update item. It edits an existing item's attribute or adds a new item to the table. If it does not already exist, you can put delete or add attribute values. Okay, so I think there was, yeah, this page right here. It's a really good guide, by the way. DynamoDB guide, really recommended. It's a really nice set of articles which you can use to learn DynamoDB from the very basics. It's just beautiful. I mean, everything is just structured really well. So you can use that if you are learning DynamoDB. I really recommend it. Let's see. Updating, using the remove, deleting items. Okay. So we can do put item operations for inserting, and then update expressions. So for that one, we are using the update item operation, and then we're doing the update expression right here. So The set. So the thing is that I guess we will have to use like I don't really like how that. Yeah, because I mean the thing right here is that whenever we're creating a new user, we're going to be populating this thing with the created ad value as like so here's the conflict, right? So we had to do the update system because when we update this thing, if you remember in the base model, we're using this updated attribute inside of the table. So that applies to all of our models and basically all of our registers inside the database. However, if we do the lazy path, which is just doing another put item inside of the update method, we're going to overwrite the whole record inside the database. Instead, what we should do is to write, this is going to be so, okay, I think I'm up to the task though. I think it's going to be quite funny. So what I mean by this is that we can update a lot of things, I think. Let's see what type of information can we actually update, because I'm not sure. We can update the email, the username, the password, the image, and the biography. So basically everything, yeah. Yep. Yep. What we're going to do is just build our own query. Like, it's probably not that big of a deal, but yeah. Let's see then. So for this, we're going to do client.update item. So for this, we need the context and then update item input. So classic table name, AWS string d dot table name. And then what else do we need? We need update expression, which is the one that we're going to build, which is this thing right here. Then we have the expression. Oops. I don't even know. Wait. Expression attribute names, and then we have expression attribute values, which is both of them we're going to build. I think. Yeah, pretty much. We need to. So, what are the types of these two things? Map string string and then map string type attribute value. Okay. Nice. So I guess it's not going to be that terrible. Yep, so we need to pass the string right here, so we're going to build that one. So how can we do this? Let's see. So the thing is, we can do an update inside of this method and just receive like the raw payload. And update it as we go, or generate a new user entirely, a new user model, which is probably not what we want. Do you know what we can do? We can do another model, which is literally just this thing. Without the base model, because we don't care about those. Those are not going to change. So we can do an update user right here. And then we would be like, so let's see. So I guess it defaults to a 0 value. Let's see, let me just check this. Let's just check this out. So let's say we have a struct right here, and then we have an email, which is a string. We have a username, which is also a string. And then we can just do something like user. And then let's say that the username is just empty for now. Right, so let's just do new user dot email, and then let's just do new user dot username. So let's see how that goes. Let's see. So that should be empty, right? Yep. It prints empty and then it's just empty. Okay, so we could just check if it is empty, we're going to leave it like that. If it is not empty, we are going to update it and put it on our update expression. So we're going to build our expression right there. Oh, and by the way, since we're doing this with the password as well, I think we need to hash the password in this layer. So forget what I said, we're going to hash the password right here. So we're going to use bgrep for that, because I'm lazy and I don't want any weird hashing or cryptography things. So go get, okay, nice. So we can now just use bcrypt generate from password, why is it not working, dude? Come on. So it's literally like new user, password, I mean it's not even hashed, and then we have to do, yep, byte to convert it, and then we can just do the cost, which is an integer. I think there was something called default cost. Okay, nice. It started working somehow. I don't know why, I don't know how, but sure, why not? So let's call this hash error. If error, we're going to do could not hash user password not be. We're just putting the error right there. Then new user dot password equals hash. Sorry, hash. Okay. So yeah, we're literally just hashing the password over there. Nothing too fancy, nothing too exaggerated. So for this update expression, we're going to iterate over the user update struct, and then if the user update struct has a field set, for example, in here, if it has the username set, what we're going to do is just append part of the expression. So I think they all start with set, so we're going to start with that one. So as you can see inside of the here, they all start with set, and then you will start doing this like hashtag dop, which is corresponds to this expression attribute name, and then this colon dop, which corresponds to this expression attribute value. So for each attribute that is set inside of the struct, we need to append this thing right here. So let me just check like that. DynamoDB update expression. Using update expressions, DynamoDB. Okay, so we need to separate it by commas, and then the last one does not have a comma, so we have to be aware of that one. Yep. Set related items, product reviews. We can also use direct names over here, so if we don't want to complicate this thing, we can just use, like, you know. Okay. Reflect. Runtime reflection, allowing a program to manipulate objects with arbitrary types. The typical use is to take a value with a static type interface and extract its dynamic type information by calling type off, which returns a type. Damn. Do you know what? I think we're going to just do it manually. I mean, I don't think that's an optimal solution. Like the reflection or reflect. Yeah. The reflect package. I don't like this thing. So we're just going to do it manually. So let's see. So if user update dot username is not an empty string, so then we're going to do update expression, and we're going to append at the end, so we need like space right there. So we need to append username and then equals colon username, which is going to be the one that we're going to use over there, and then if user update dot bio is not equal to an empty string, update expression, we're going to do I think we should do like a comma right here, and we're going to remove the two last characters in the last iteration, or sort of like the last processing step of this. So we're doing bio equals colon bio. So I guess we can just like replace this thing. So the next is email. Then we also need to check for password. And I think lastly is the image. So we're going to do this. We're going to do this. Comma space, comma space, and then oops, comma space, and then last but not least, our image. So image. Okay, nice. So update expression will be equal to update expression of update expression, and then we need the size of this. I think it was something like length of update expression -2. So we want everything up to, or sorry, not this way, but this way. Okay. Update expression. Okay, nice. So let's say, for example, I will try this on the it's never used. Sorry. Update expression. Okay. So yeah, we're literally just removing the last two characters, which are just like this space right here. So this and then the other one. So by the way, I'm going to do so what if let's see. So if there are no values to update, that means that our original string is going to be just 4 characters long. So we're going to do just that one. Len of update expression is 4. Then we'll just return nil. Anyway, we need to return an error right here. Nice. Okay, and then lastly, we need to do expression attribute values, which is just a map of string type attribute values. So we need to define that over here. So we're going to do just that. I think this is a signature. Yep, attribute value. Okay, nice. So we will remove this one, and then we're going to do this right here. Sorry. Wait, is it really? Attribute value. What? Map string types attribute value. Map string types that attribute value. What? Variable of type map string. As map string. Well, this is kinda not optimal. What? Wait, why am I... What? Oh, wait. Oh no, what? This thing is so weird. I'm telling you, I just hate this LSP. Like, I don't even know why it's so bad, but whatever. So now we need to populate this map, and what we're going to do is so for each one of them we need to let's see. So we need to do the column one, and then as the value. Okay, yes. So expression values. I think we need to initialize this thing. Do we? Do we? I think we do. Colon username equals types dot attribute value member string, and then what we're going to do is value. I'm going to do user update dot username. Okay, nice. This is looking pretty good. Let's see, colon bio, oops, colon email, colon password, and then last but not least, image, nice. Yeah, that's basically it, I think. And then finally, I think we do need to update the updated at field. So we're going to do, I guess we wouldn't need to do this then. Update expression, let's go into append. Let's see, so that would be updated at UPD. So we need a string of the current date. I think we can do that with just time dot now dot format. Wait. Let's do date time for this. Nice. Okay. Okay, looks like it's time for a break. Let's see. So I think this update method is pretty decent already, I think. The only thing that we're missing is the key, of course. So we need to do something like ID, or user ID rather, which is going to be a string. Then the user update information, which is what we already have. So I think we can just do something like key right here, and then we need to do our PK and SK over here. So let me just finish with this. What is the type of this? By the way, map string types, attribute value. Okay, so we need to do our PK, which is going to be user, or rather, let's just do printf user, and then let's just do d user ID, and then we can just do the same thing over here. So sk, it's going to be user, and then just that one. Okay, nice. So I think, yep, we need to wrap this around. Wait. Okay, nice. So yeah, we're going to use, I think we're going to use UUIDs, by the way, so that's why I'm using the user ID as a string and not as a number. Basically because, I mean, it's just kind of cumbersome to have a auto increment in a database that doesn't provide an auto increment natively, I think. Pretty sure it doesn't. And if it does, I mean, UUIDs look better, so anyways. So yeah, we're going to start the break right now. We're going to be right back in 10 minutes. I'm going to put the timer in the screen on the waiting one, so just give me a second, wait. Okay guys, we are back on track. So I don't think we will be able to finish this timer, so it's going to be like around 30 minutes probably. Not the full 50 minutes, but we're going to try and get the most of, like the most part of the CRU operations inside the database for the user store at least. So yeah, let's get straight to work. So let's see, where were we? Oh yeah, we were finishing the update user method. I think it, I mean it's, wait, let me see if I'm missing something. I don't think I am. We have all the keys, we have all this stuff. Yep. So by the way, I think it's a good time to define the fact that we should actually be defining these PK and SK attributes inside of the database layer, because I don't think it's a good practice to do it inside of the domain layer, because it's just a concern of the database. So I'm going to start and define those right here. So for the user, as you could see over there, in the update one, we're going to use this PK and SK inside of the user record, so to speak. And also, we want to define the type attribute. So if you remember, inside of the base model, so right here, if we go to the base model, we have a PK, SK, created at, which is going to be defined as the time where it was created, of course, and then updated at, which is the one we are updating inside of our database. Let me just clean up this thing a little bit. User store.go. So the updated at value is the one that we are using right here. Updated at UPD, and there we're inserting the value of time.now.format, time.datetime, which then we can parse, and then we can compare inside of the using Go in the server. So what we want to do now is to populate those base attributes. So base model, we need to populate these 5 attributes inside of our create new user method. So for that, we're going to do new user.pk will be equal to user, and then we're going to use UUID as I told you earlier. Go UUID. So we're going to install this UUID package. Go get GitHub Google UUID. Oops. So we added the package, and then we would just need to do, so I think it actually generates an error. UUID new string, and then we have, let's see, no, it just returns one value. Okay, so just the UUID. Okay, nice. So we can just do that, and then we can just do the same for the sort key. Then we can just do created at, which will be time.now.format, time.datetime, and then finally we need our type. So user.type. We're just going to store a user information right here. Okay, and then the updated at, we're going to leave it empty, of course, because we haven't updated it yet. We're just creating it in this method at least, and then on the updating method, sorry, we are modifying that field right here, so we are reflecting the updated time in which we invoke the method, so to speak. Okay, so we have the creation of a user, we have the updating of a user. Sorry, I just don't know how to type. Don't know how to speak. Okay, so and then we need the get user method now. So this also returns an error, and we will need our context, of course, classic context.context, nothing new under the sun, and then we need our user ID, which is going to be a string, which is going to be useful for querying a single user. So inside of the requirements, when we get a user, so we can get So we can get the current user, or we can get the profile of the current user. So we're using the username for this one. So what we can do is, when we are creating the user, let's see, how can we do this? So of course, not allowing spaces, not allowing special characters inside the username. And why am I saying this? Because we need to create a username, like username ref, so to speak. So the way we're going to do this is, alongside with this one, we're going to put another item. So put item context DynamoDB, put item input, so table name. Okay, and then we're going to do this. So let me just check another thing. Let's see. Yeah, we just need the item. Nice, okay. Okay, then let's see. Map. String. Okay, nice. So for our PK, we're going to do the same thing. So we're going to do user, and then we're going to do plus UUID. I guess this has to be wrapped around. Types attribute value S, and then value. Now we can use that one over here. Okay. Okay, so for this one, we need to put the username as the slug. So let's see. Oops. So I believe we can do something like this. So let's see. So let me just think. So we are querying a username, and then we need to. Okay, yeah, I think I got this. So we can do something like user ID. Okay. So So what about querying this? I think we can just do something like this. Yeah, so the only issue I see with this is that we would have to update the username ref as well as wait, let me see. I think the AI gave me an answer to this not too long ago. I don't even remember where that was. Let me just see slug here. Okay. So we're using this, and we're using that. Okay. Yeah, so how about updating? Slug. So we can use also a global secondary index for this one. Again, I'm not even sure how that works, so I'm not going to implement it just yet. But I'm going to do some research, I guess, and then we're going to implement this part of the system. Let's see. Yeah, so this redirects to the article ID, which is this one right here. And then in this one we are also storing the slug, which is, well, I mean, it applies the same logic as the username. So, let's see. How to DynamoDB. Slug ref. Yeah, I think that makes sense. So we will stick with this system for now, and then if I find necessary to implement a secondary index, like a global secondary index, I will, but again, I'm not entirely sure on how that's used, so we will leave it to later. But I think for now it is enough, so we're going to keep going with the get user. So for this one we're going to query it by the username. So let's see how that goes. So for this one, what we really need to do is just a get item query. So We're going to query for the user ID for now. Then DynamoDB, get item input. Let's see, what do we need for that one? Retrieving items, get item. Let's see, so we need our keys. That's basically it. Okay. Table name, AWS string, b.table name, and then we need our key, which is a map of string. Okay, nice. So we need our PK, types, attribute value member s. Let's see. We need this to be user, and then what types? Okay, now so we need to do another query, which is going to be for retrieving the exact user. So, by the way, this is kind of clutch already because we're literally doing a checkup if the user exists before even retrieving the user. So it's just kind of like useful for doing those two functionalities at the same time, because optimally and ideally, let's say, you would have to check if the user exists before retrieving it, right? So with this, we're literally just like skipping that step because we're doing it in one go. But anyways, user error. Let's see. So what is user ID? That's the situation. Get item output. So what do we need for that one? I guess we can just like define a local struct. So we can just do something like, what are we retrieving? We're retrieving a PK, an SK. Then we're also retrieving a type. And then we're also retrieving the user ID, I think. So let's see, what's the exact name? It was username ref user ID, yes. Okay, nice. Oops, sorry. Okay. So what we can do is just to parse this output. So how do we do that? Input, get item, let's see, coupon, on Marshall map. This one right here. So we get the item out of there. Then we can do if error right here. Okay, and now what? Oh yeah, we need to stop it. So for the get method, we also need to return the actual item, right? So models.user and then the error. Okay, nice. So we're going to do d.client.getItem, and then we pass in the context. Same setup as usual. We pass in the table name, d.table name. Then we also need the key expression, which is a map string attribute value. So we need our PK, which is going to be types dot, let's see, we're going to use s, we're going to do user, and then we're going to concatenate user id dot user id. Nice. Then the same goes for the sk, right? We can just copy this really. Okay, nice. And then I think that's it. Yes. So by the way, this needs to be like a pointer because I want to return nil in case that we could not retrieve this. So over there and over there. Oops. Nice. On Marshall map, this doesn't return that. Oh yeah, that's true. I'm dumb. Okay, so now we have a user which we can actually unmarshal. So user models.user attribute value dot unmarshal map. So we can just call this on user dot item, and then we can do this over user. So let's just call this user info. And then this should be an error, so if there's an error, right here, and we can just do something like this again. Nice. Okay, I think that's pretty much it for the user store. I mean, we need let's see, get current user, get update user, get profile, which we can use the same user as well. So we can just do this get user. For the get current user, we can also use the same get user, but we would need to do it with the information inside the token or the session, so to speak. So I mean, it's not like a session, but it's just like an ID token. We're going to use JWT, by the way, for the authentication. So yeah, that's pretty much it. I think we can also do the following system, but I think we can do this following thing outside, maybe, like in another store, or maybe we'll do it right here. I don't know. Could be a decent enough idea to do it right here, or maybe not. Who knows? I think we'll do it right here. Why not? DynamoDB database. Let's do follow user. So context.context, and then we need to do username, which is going to be string. So of course we need to get the user that's going to be followed. So I mean, we need both, right? We need the user that's going to be followed, and then we need the user that's currently following. So we're going to do follower, which is going to be a string, follower ID, and then followed username. So yes, the ID, we're going to get it out of the JWT, as I was saying. The username, we're going to get it out from the URL. So right here, you can see that we have the username inside the URL. So we're going to model it so that we can just pass down that URL parameter. So for this, we're going to return just an error because it's a post request. So return nil in case that everything goes fine. And let's see. So we need to use our client, and we need to do get item. So the get item input, and then we need a table name as usual. String, need our table name. Then we also need a key, which is just a map. Oh, and by the way, we already have like this method. What am I doing? User error, we're going to just do d.getUser, so ctx, and we're going to use followed username. Okay, so let's see, we're going to, so for the followers, we will need to retrieve our user ID. So I think we could separate this thing into its own method, I think. So we could abstract this from here. We could do something like DynamoDB database get user ID from username. Context, and then we'll just grab a string right here. We'll just return a string and an error. We'll just paste this thing. We're going to return an empty string if this doesn't work. So we will do user ID dot, oops, user ID and then mail. Okay, nice. So now right here we need to do, okay, okay, nice. So we just abstracted this onto its own method so we can get the user ID directly. So we can just do the same right here. Get user ID from username. We're literally just doing the same. Okay, so now we got the user ID, which is literally just a string, right? User ID is a string, so now we can just query it directly and then just put the item inside the database, like the reference, I mean, directly. So what we can do is just client dot put item. So we need to put 2 items because we said we're going to do the inverse relationship as well. So we're going to pass in the context and then, oops, put item input, table name, string, d.table name. So we are going to do so let's see, this is what we're going to do. So we're going to use APK, of course. Types, attribute value member s. So for this we're going to use the user ID. So user hashtag, and then we're going to do, we're going to change this to followed ID, just to be a little bit more specific. Or actually we need this, we're going to do the follower ID first. Then we need the SK. So type, sorry, as value, and then followed, and then user. Then we're going to concatenate the followed ID. Nice, 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 nice. So we're going to copy this over. We're going to change a little bit of things right here. Followed ID. By the way, we're going to change this again because I hate having 2 naming conventions. Followed ID. And then this is going to be a followed by relationship. We're just going to put follower ID over there. Okay. Nice. We're inserting 2 items. I think we can do batch write item. Let's see, what do we need for this one? Context, params, optional functions, batch write item input. Let's see, what do we need for this one? Let's see. DynamoDB. Let's just see. Request items. So what's the type for this one? Oh, we need to do Okay, nice. So you might be asking, why did I bother even doing this? I'm pretty sure it is because the batch write item operation just treats this whole thing as a one single operation. I'm not entirely sure. Let me see. Um, the entire request, you could have individual write requests, most common. Let's see. Write capacity units. Let's see. Here is the relevant documentation. 25 writes up to 25 items. Then when we process each item in the batch as individual. I mean, I think I could have just left it out as individual put operations, I think. Yeah, I think it's kind of like just an efficiency thing because the write capacity units is still it spends the same capacity units, so it's not just like a we're spending the same amount of money technically, so it's not a big improvement. But I mean, I guess it's just look better. It looks better for me than just having two separate requests. I mean, I think that just looks kind of ugly. So yeah, we're leaving it as a batch write item. It's just two requests. It's not that big of a deal, so I'm going to leave it like that. Okay, and then we are going to check the error, of course. So if error. Okay, nice. So that's basically it for the follow user. I mean, it's really simple. We're literally just creating a new record inside the database for the following users. And then we're going to query this by selecting, for example, if you wanted to query all the followers of user numeral, or sorry, wait, what? My bad, okay. If we wanted to query all the followers of a single user, we could literally just use this one right here. So what it means is, if we wanted to query, for example, so let's say that my username was Fernando, right? And then I wanted to query all of Fernando's followers. So then what we will do is that we already have the username, which is Fernando. We call this method, and then we're going to check out for all of these SK, so our PK, we already know is going to be something like user Fernando, right? So maybe like a UUID right here, because we are going to use the username ref to get the UUID to get the information of the user. So we have our user number UUID, which we already have, and then our SK, it's going to be followed by, and then whatever, right? So inside of DynamoDB, there's this useful feature which we already use, which is called the expression attributes, or like expressions in general, which can be used alongside queries, which are a special type of querying mechanism. We also have scans, but scans are ugly, so nobody's going to use them anyways. So inside of the queries, we can use expressions, and with those expressions, there's a method called begins with. So we can use the begins with method accompanied by this followed by, which we already know it's going to be a constant in all of the SKs that are of type followers. So we are literally just registering that inside of the database. We are going to use the begins with method to query out the followed by relationships, and then that will allow us to essentially query out the information of the users that are already following me. So all of my followers will have this record associated with them, the followed by. So that's what allows us to just query out the information of the users that are following me. So to avoid making more and more and more calls, what we can do is to embed all of the information of the user directly in these relationships. So instead of using something like a relational approach, which would be, oh, there's a following relationship, that we're going to store the ID of the user that is following me. Instead of storing the ID, we're going to store the complete register of the user. So remember how in the create user thing right here, we were storing the whole user model, right? So the user model, as you remember, has 5 main attributes, which are these right here: email, password, username, bio, and image. So instead of storing just the ID of the user, we are going to store the 5 attributes directly in the relationship. That will allow us, and that's what makes DynamoDB really powerful and also really confusing, that will allow us to, instead of making 2 API calls and wasting 2 read capacity units, or potentially more, of course, if we are retrieving a lot more users that are following me, instead of making 2 separate API calls, we will be able to just do once and retrieving all of the user information in one single pass. So this is also really useful because since we are storing data that's fairly small, or that's not that huge, maybe like inside of the bytes even, spectrum, so to speak, maybe each record is, imagine it's like, what, 400 bytes inside the database. So each of the user records is going to waste 1 read capacity units by itself. So what does that mean? I think there was, let me just check. I just saw, I'm pretty sure I saw, and I saved it, by the way. Where did I save this? Let's see. Other markers. I didn't save it. What? Oh, but it's right here. This blog also, it's really, really good. Let's see, there it was, I think, a filter. Here, okay. I think there was an area right here which he explained. Read, spread, okay, I think it was like right here. I forgot where that thing was, I think. Read consumption, okay, this area right here. By the way, this blog is really good. I really recommend it. It's really nice. It's also just, I think it's the same person that wrote this guide. Man, this dude, Alex Debris, I think it's called, he's a complete goat. Like, you know what I mean? Like, in a world where there's no information about things like this, like DynamoDB is just a really scarce database in terms of information and documentation, I think this is just like a lifesaver. It literally sums up a lot of the good patterns and all of the good information that you need to know in order to start building nice and scalable DynamoDB applications. I mean, it's just such a great blog. It's such great information. It's such great everything. Shout out to this guy. So in this area right here, we have the read consumption section. As you can see, each read capacity unit, which is like the unit in which AWS builds your usage of the database, each capacity unit is up to 4 kilobytes, but it rounds up. So what do I mean by that? If you query a single object that's 1 kilobyte, it will cost you an entire read capacity unit. So we have the possibility to query 4 items of the same size, but we're going to waste 3 entire kilobytes by just querying a single item. What do I mean by this? Imagine that instead of embedding the whole information inside of the relationship, like we're doing right here in the followed by sort key, imagine if instead of embedding the whole information, we just embedded the ID, just like in a relational model. We would have to first query all the IDs, store them inside of an array, and then query all of the user information in a separate API call. What does this mean? This literally means that we are wasting twice the same amount of read consumption or read capacity units just because we didn't model our data properly. And I know that this is just like an insane conflict for people coming on a relational or SQL background, because they say something like, well, that's not normalized, you're literally duplicating information. What about if the user changes blah blah blah, and then you're changing this, and then you have to change that, and that's not consistent information, and that's just insane amount of work. Well, yes, it is. I mean, it is literally a trade-off. Like, you have to think about it this way. It is a trade-off in the sense that you are not getting this for free, right? You are not getting this ease of access to information for free. Of course, you're going to sacrifice some things, but it just makes it way easier if your users are not going to change constantly. So in this application and for this purpose, of course, we're not going to think too much about this data consistency, because I mean, you would have to inside of the update method right here, you would have to make sure that all of your attributes are up to date with the one that you are inserting, right? So if a user changes, I don't know, the email, you would have to change all the information inside of this relationship as well. So you would have to make sure that every data is consistent across the entire database. But again, I think you would have to do a lot more, you would have a lot more consequences if you literally just put the ID inside this relationship. Like, the consequences will be monetary, right? You will have to pay more money just because you didn't model your data properly or according to the standards of DynamoDB, like the things that the database is expecting you to do. So that's why I think it's just a better and way more sophisticated approach in this context specifically, not necessarily in all contexts, of course. Again, I know that a lot of SQL purists are going to be mad. I know that it just triggers them to think about duplicating information, like that's just like a sin for them. But in this case and in this situation, DynamoDB, it's better at handling duplicate records rather than just relational or join type relationships. I think it's just way better to do it this way. So I think we're going to leave it like this. I'm going to put the rest of the attributes over there. So I think we would literally just need to embed the rest of the attributes for the user that we're going to query. So yeah, I think that's basically it. We're going to leave it at this, like this, in this session. I'm going to keep working off cameras. As I said, I'm going to keep investigating about the global secondary indexes or indices, which are a big recommendation and a big suggestion that all of the forums and information outside just suggest you to implement. I know the pricing is going to be a lot bigger because of that, because I think the global secondary indexes have their own capacity measurements and all of that stuff. So, you know, as long as you don't use them excessively, I think you're going to be fine. But again, I don't know, I don't even know how to use them, so I'm going to investigate a little bit. I'm going to do my own research, and then I will come back with the results. So thank you for tuning in. I think it's going to be a really fun project. Just literally look at the simplest and most direct operations that we're doing, and they are already very, very sophisticated. We're not even implementing cache yet, and we're already running into so many troubles and so many things that we need to take into consideration. So I think it's going to be a really nice project. Hopefully I will finish this in this week. I'm very, very convinced that I can finish this week. As you can see, this is the hardest part. When we implement the rest of the application, the upper layers is going to be much, much easier because we already have this abstraction, sorry. So yeah, I mean, I think the rest of the application, the routing and the domain layer, the validation of data, the requests and all of that is going to be really easier. So yeah, I think this is going to be it for me for now, and we'll see you in the next episode of this series. Goodbye.